This question has looks like stair steps kind of graph, and it's asking us three questions. Where's the limit defined? Where's the function continuous? And where's the function differentiable? Okay, well, the function is, first off, where's the limit defined? Let's talk about what it means when a limit is not defined. If you have a graph that kind of comes up like this and has a solid dot there like that, and that wasn't a very good solid dot. Here, let me do this. It kind of comes this way. Okay, then maybe solid dot there, open dot there, whatever. So right there at that point, the limit would not be defined because for a limit to be defined, it must be the same from the left and the right. So any place where it's not the same from left and right, it's not defined. Well, we can see right here at 1, it's here and then it's up there and right there at 2 and right there at 3. They're all a problem, aren't they? They're all a problem. So we're giving the answer right there. That does not include the 1, does not include the 2, and does not include the 3. Now, let me help you see that. You might be saying, well, how's that any different than just saying like 0 to 4? They just said it in a bunch of pieces. Yeah, they did say it in a bunch of pieces, specifically because 1, 2, and 3 are not included, which is exactly right. We want to say everything from 0 to 4 is okay, except not right there at 1, not right there at 2, and not right there at 3, because those are not the same from the left and the right at 1, 2, and 3. Everywhere else is good. Like at 1.5, it's good. At 2.5, at half, and all those other places in between at 3 3/4, all those places it's meeting up left and right. But right at 1, 2, and 3, it's jumping. It's not the same left and right. Now, are you clear on interval notation? If I write an interval like 0, 1, do you realize that means 0 and 1 are not included? Parentheses do not include the edges. Whereas if you write like, let's say 0 with a bracket, 1 with a parenthesis, that means 0 is included. 1 is not included. So you can put brackets on both, parentheses on both. You can mix in one bracket, one parenthesis, whatever. If you write it this way, you're saying we include the 0. We're straight. Brackets have a straight edge to them. Just think about like you're straight on that point. Whereas parentheses are rounded, meaning you're around the 1, but you're not straight on the 1. You can do 0.999999, but not right on 1.0. No, you're just close to 1. You're around 1, not straight on 1. So the point of that is when they put a parenthesis on the 1 there and a parenthesis on the 1, that means 1's not actually included in either interval. Same thing with the parenthesis on both the 2's. 2's not actually, they put a bracket, then that would include the 2, but they didn't. And they put a parenthesis on both the 3's. So that's how they're saying 1, 2, and 3 are not included. It basically goes everywhere from 0 to 4. It just does, but it doesn't include. So it's the same as saying 0 to 4, but it doesn't include 1, 2, and 3 specifically because there's parentheses on all those numbers. Now you might say, hey, Mr. Aaron, at 0, there's a solid dot. We should be including 0, 1, 2 to bracket. Well, right down here, it said for each interval, treat the endpoints as not included, even if it looks like the function continues. So they specifically said, don't include the endpoints. Don't include the 0. Don't include the 4. That's why they're putting parentheses there. All right. Next part. Where's it continuous? Now you know continuous just means it you don't pick up your pen. So if I'm drawing here, and I got to pick up my pen, come up here, pick up my pen, come up here, pick up my pen. So it's going to be the same thing at 1, 2, and 3. It doesn't continue. So same answer. And then the final one, differentiable. That might be a new word for you. That means smooth, not jagged. So for a function to be differentiable means it's smooth, not jagged. Let me show you an example. So say I've got a function that goes like this. And then right there, see how that's a jagged spot right there? We would say right there it's jagged, it's not smooth, it's not differentiable. So to be differentiable means to be smooth. So it's like the highest level of niceness. These are increasing levels of niceness, right? So first off, we say, hey, is the limit defined, meaning same left and right, and then even a higher level, where does it continue? It's always connected, and then not only connected, but smooth everywhere, increasing levels of niceness. So where is it smooth? Well, it's going to be the same answer on this one anyway, because it's not smooth where it's not connected. So it's got to be connected to be smooth. So it's not even connected at 1, 2, and 3. So same answer, everything from 0 to 4, not including 1, 2, 3. It's not smooth there. It's not continuous there. And the limit isn't even defined there at those 3 points. Everywhere else is good.